My name is Dmytro, and I'm the guy responsible for Uklon's iOS applications. Uklon, for those of you who aren't familiar, is a ride-sharing service. And on iOS side, it has two main products. An application for a rider, where a user can request a ride, and an application for a driver, where a user can accept a ride or not. So today we're talking about test-driven development, and TDD by no means is a hot new topic. So why are we bringing it up today again? Well, first of all, we're going to talk about TDD on iOS specifically. And if you think about it, in order to your code to be covered with unit tests or any kind of tests, you have to know all the possible inputs that your functionality can accept and to have a predictable output for any given input. And so the important thing here is that the concept and framework of TDD wasn't developed with user interfaces in mind, and let alone mobile development. What's so special about mobile development? Well, if you think about it, what a typical iOS application does. Well, although I can't speak for everyone, but in our case, most of the time, the front-end application just draws animations. To no one's surprise, the app itself doesn't calculate your ride fare. It does not choose the best route for a driver to take. Neither it matches drivers with riders. Basically, a front-end application just receives all the work that is done by backend and draws animations. And also, iOS application lives in a cruel world where it can receive inputs from all sorts of sources in any order at any time, and it all has to handle it all gracefully. So the most effort we put in our iOS application is to basically for it to look pretty. So back in the day, when I've been researching the topic of TDD on iOS, I must know that I come from a perspective of someone who started with iOS development already having some idea about TDD in mind, how it should look like, why we should we bother, and how tools for TDD should look like. So my big question was not, hey, I'm an iOS developer and what is TDD? It was more like, how the hell can I apply it here? Not even to mention that tests must be written before the code. So my goal for today's talk is to give you my personal answer to this very question. And in order to do this, I will show you very specific examples of how we in our team applied test-driven development in our iOS development and benefited from that in a very direct way. But also, I will show you a couple examples of how we used tools for unit testing, but completely outside of the context of TDD, and benefited from that even more. Well, first things first, we will start with defining our terms, what we call TDD, what we call unit tests, how they are not equivalent, just so that we are all at the same page. Then I will share my success stories. Then we'll talk about situation in which you may choose other solutions than TDD, even better than TDD. and we will end up with discussing a couple anecdotal artificial examples of how things can go drastically wrong. In fact, so wrong that no amount of unit tests will help you. And I completely acknowledge that these examples are very artificial. I just find it too funny that they are possible at all. Oops. Hope you don't mind. So, to distinguish between terms unit tests and TDD, let's start with question. Well, if I write unit tests, obviously if there are two different terms, they mean different things. So just writing unit tests isn't enough to claim that you apply TDD. Even if you write a lot of tests, this doesn't guarantee that you apply TDD as well. And if your tests are always green, obviously that's not enough either. Well, originally, test-driven development isn't called test-driven for no reason. The idea is that you really have to write tests before you write an implementation. And the reason for that is that you can write the same implementation in different ways. And when you start with thinking about how you will unit test your implementation, it will force you to think a certain way and design your APIs in a certain way. Next up, we probably heard about red-green refactor cycle. And the order here is important. And a red-green refactor cycle starts with what? It starts with red. So when writing your unit tests, it is crucial so that you make sure that each and every test you write can fail. And what is the best point to ensure that? Is before you write an implementation. And here, at this point, you are guaranteed your test will fail. And this is very important to make sure that each and every test can fail. Although you can benefit from writing some unit tests, but something magical will happen when you can cover your functionality with so much tests that you can be sure that if your code contains a single bug, there will be at least one unit test that will point it out. And I cannot emphasize enough, tests only matter if some of them will fail when your code contains bugs. So your unit tests exist not to ensure that everything is correct when everything is correct. They exist to let you know that something is wrong when something is wrong. Why to bother with this TDD thing? Well, it is promised that if you follow all the rules of TDD, you can receive following benefits. First of all, test-driven development helps you find well-hidden bugs that are hard to find otherwise. Also, your test suite provides you with, your exhaustive test suite provides you with the documentation. It describes what your code does. And it is much easier to read your test suite instead of reading your implementation code. And also, when you have a piece of code that is covered with unit tests, with sufficiently high test coverage, you can allow yourself to refactor it more aggressively and still be sure that everything works as intended. And also, as I mentioned, I will show you a couple of unconventional ways we use tools for unit testing to get additional benefits. but I will explain it in details later on. So now let's take a break from its theory and dive right into the stories. First off, a story about finding bugs. Back in the day, our task was to integrate with a third-party service that used custom cryptographic algorithms for authentication. And thus we were forced to implement some homebrew cryptography. As an input, we were given, thanks God, working Java code. And basically our task was to translate it to Objective-C. If you think about it, how do you even debug cryptography? The whole point of a good cryptographic function is that it makes it unguessable what is wrong in an input based on output. So even if a single bit is changed in an input, the output should look unrecognizable. Thus, not having much choice, what we did is we ran the Java code, we saw what output it produces for a given input. Based on that, we wrote our unit tests. Then we wrote an implementation, made sure tests pass. Here we have a chance to refactor a little bit and integrate whatever we ended up with into the app. And the app worked for my first sight. And then our QA engineer got his hands on it, and it stopped. Well, during development, the code was tested on the best iPhone ever made, which back in the day was iPhone 7 Plus. And our QA engineer tested it on iPhone 5. So what is the difference? What's so special about iPhone 5 compared to iPhone 7 Plus? Well, if you recall, back in the day, iPhones used to have a 32-bit processor architecture. And around that time, they moved to a 64-bit processor architecture. And our cryptographic algorithms relied heavily on bitwise operators. So it hints that something is wrong, meaning some bitwise operators probably behave differently. Well, imagine the scenario if we didn't have the test suite by this time. If life wasn't hard enough by this time, how funny would it be to debug the same code on an iPhone 5 and then make sure we didn't break anything for iPhone 7 Plus? Well, fortunately, we did have a test suite. And just a single run of a test suite right away pointed out to the problem with the bitwise shift. And our problems has been solved in a matter of minutes. Now for me, that was a moment of realization that this whole TDD thing actually works and it really gives you a superpower. And with this happy ending, I conclude that test during development really does help you to find certain bugs rather quickly, much quicker and much easier than you would do before without them. Now, moving on to the story number 2. Our application needs addresses. And here's the important thing. Different cities may contain streets with the same name. And when you request a ride, you really want to be sure you pick the right one, meaning the street in the city you intended to go. Also, if you want to request a ride to some, say, mall, it is helpful to see for both parties to see the generally recognized name for the small, but also to see the exact address. And the thing here is that this information used to be delivered to the front end as a single string with semi-expected format. And so it was the responsibility of the front end to parse the string, which we did with help of some regular expression. And by the way, parsing a string with regular expression or without it is a task perfectly coverable with unit test. And so the story could end right here. We found another task that is perfectly coverable with unit test. However, it gets even better. Now, if you think about it, it makes all the sense in the world to delegate the job of parsing a string to a backend so that we don't run into a risk for this same string being parsed differently on different front ends, as we have 3 of them. The only thing is, up until this moment, backend team didn't care much about how string looked like. And all of a sudden, now they started to care. Initially, the question for us was, well, give us an implementation code how you parse the string. And answering this question directly would include giving them a regular expression with some pieces of Objective-C code. And people usually don't like reading neither of them. Well, thankfully, we did have a test suite for this task, an exhaustive test suite, which provided all the information the backend team needed. How string may look like and how expected output for a given input looks like. And with that, I must conclude that your test suite not only provides you with explanation of how your code works that is easily readable for you, but also it is easily readable even for your colleagues involved in different technologies. Moving on to the story number 3, on making refactoring less risky. Our application also needs to parse and validate phone numbers. And it does it quite a few times on quite a few different screens with a little bit different designs. And just to give you a rough idea of how many times we needed to solve this very problem over and over again. And solving the same problem over and over again gets really annoying really quickly. Especially considering that all the rules for validation remain the same from screen to screen. And basically the rules are: user can pick a country code, and it can enter a phone in a text field, supposed phone number. And then application, every time the country code changes or the input in text field changes, has to revalidate and to answer a question, does a given entered phone number constitutes a valid phone number for a given country code, and update UI accordingly. Now, for a given entered text, to answer the question of does it constitute a valid phone number for a given country code, this question is delegated to a third-party library. All our application needs to do is to ask it over and over again whenever user input changes. And this logic, although can be copied from place to place, but it really begs to be reused. In search of ways to reuse this functionality, we utilized functional reactive programming, and I mean reactive Cocoa by this. I hope you are familiar with the concept of functional reactive program, as we now have combined Apple-approved way to do this. And basically the idea here is that whatever input we have from the user's input is presented as a stream of events. And now we're not working with text fields. Instead, we're working with the stream of events. And accidentally doing this makes it possible for us to cover this functionality with unit tests. Because whatever string of events is produced by a text being entered in a text field, it can also be programmatically emulated with the help of subject. And this is how it looks like. We have this component, we call it service in this case. It expects as an input a signal, and signal is a stream of events. Now, inside the application, we feed it the real stream of events from a text field. However, in a unit test, we can feed it with a subject. And we have full control over what events subject emits. Now, this whole functionality, completely detached from UI, can be covered with unit tests from top to bottom and easily reused between screens and even projects. In fact, while developing this piece of functionality, we started with writing test suite. And I was so sure in this test suite that I didn't bother to even take a look into implementation and just delegated this work to a colleague of mine. And years later, when we decided to give it this component attention, update dependencies, refactor it a little bit, again, I was able to delegate this work to another colleague of mine. And delegation is one of the sweetest parts of being a tech lead. Now, moving on beyond TDD, let's take a look at a couple examples of how we utilize tools for unit testing, but outside of the context of TDD. And for this one, we're going to talk about universal links. This is a widely used feature of an iOS application in which app can be opened by clicking a link, and application is totally aware of what link caused it to be opened. And so it can recognize the link and react accordingly. And our application handles quite a few of them. Now the question is how to make sure that we distinguish between all the different supposed universal links and provide them with unique response. Yeah. And again, we're talking about parsing strings. And parsing strings is a task that is perfectly coverable with unit tests. And unit tests help us here in two ways. Well, first of all, for a given URL, the test answers a question: how this certain link must be recognized. But even more importantly, they answer a question of how this very same link must not be recognized. And to give you an example of what thread I'm talking about, as you can see, we have quite a few links, each of which contains a word, a substring promo. So imagine we were trying to recognize these strings by a substring promo. We could have a problem, as this way wouldn't allow us to distinguish between them. And now, because we have this exhaustive test suite, it quite literally, in a very real way, saves us from having a contradictory requirements, which would be a result of just a human error. Moving on to the story number 5, the one with the magic trick. Sorry for that. Did I miss anything? Okay, if you remember, Uklon's writer application used to look rather differently from how it looks now. And back in 2018, it is about to get a redesign. And it started with us seeing this wall of screens, seemingly random. It is obvious that the new design is so different from the old one that we didn't have much chance, neither need or desire, to reuse any code from the previous version. And thus we are about to rewrite the whole application from scratch. Well, seeing this wall of screens and not having much choice, eventually we started to develop some common understanding about how the UI should be built. And we figured that designers constructed the new UI with the concept they called cards. And cards in this scenario are self-sufficient views of which appearance is completely defined by its content. Now, another important piece of input here, designers weren't sure that all the cards will look good on all the screen sizes with all possible contents. Meaning that on a small screen, no card will once again, meaning that on a smaller screen, any content will fit any card. And on a bigger screen, no card will feel too spacious. So we are about to rewrite the app from scratch, and our goal is to provide designer team with the quickest feedback possible on how the UI they designed will look like on different screen sizes and with different possible contents. Well, probably the question now is how unit tests can help us here. Well, again, every card has all that needs to be rendered inside it. So it doesn't depend on the context in which it is used. Actually, no need to have an application to know how the certain card will look like. We can start with marking up views before we start to write an app itself. But it would be great if we could create all the different presets for our views, mark them up, and see how they look like before we even started to write the app itself, before we have a single view controller, like in unit tests. Now the question is, can we? Well, let's consider an example. Take, for instance, this basic view. It has some label, it has some icon, image view, and also it has all the layout constraints it needs to define its appearance. Now, there is no problem to instantiate a view inside a unit test, right? And fill it with the content we need. If we have a view inside a unit test, there is no problem to take a snapshot of it so that we have it as an image. Having an image on our hands inside our unit test, there is no problem to save this image on a disk. And as long as we run our unit tests on a simulator, there is no problem finding saved images on the disk. Now, the only bummer is that before a view appears on some screen, it has a 0000 frame. And that is because the operating system is rather smart about optimizing resources and seeing that a view never appeared on any screen. There is no point to waste resources calculating its geometry. So this is our only problem. Now we need to find a way to force the system to calculate view's geometry without the need to present the view on any screen. In other words, we need to lay the view out, but not when the system decides, but when we need it. We need to lay view out when we need it. Do you see where I'm going? But your view has this method, layout if needed. And up until this point, we didn't really understand what it does. If you take a look at the documentation for this method, it turns out that the surprising thing is this method does exactly what it says. It allows us to make the system calculate view's geometry without the need for this view to be presented on any screen. Well, now we have all the pieces at place. We can write a bunch of unit tests in which we instantiate views, we'll fill them up with different kinds of contents, and we render them for all kinds of screen sizes we care about. Save them on a disk, produce a whole bunch of JPEGs, quickly take a look at how they look like, archive them, send to designers, and this is how it looked like in action. We run our tests, we get our bunch of JPEGs, we see quickly, is everything okay on all the screen sizes with all the different contents. Then we archive these JPEGs, send to designers, get feedback, make changes. And boy, we did make changes. And this way, we were able to debug our design even before we started to write the app itself. Now, how's that for writing tests first? Now let's discuss the wrong conclusions you could make from this talk. Well, in story number 1, we discussed how we developed our custom cryptography, and we started it with writing unit tests. So probably we learned that whenever you write your custom cryptography, you have to start with writing unit tests. Huh? Well, in fact, you should avoid writing your own cryptography unless you absolutely need it, or unless you're absolutely an expert in the field and you're sure what you're doing. The reason why is that not all aspects of a good cryptographic function can be unit tested. What I mean by that, if, say, you write your custom pseudo-random numbers generator, and if it produces output that is too easily guessable, you may not notice that. But the attacker trying to crack your app certainly will. And the consequences for that can be fatal. And I'm pleased to say we moved on from that implementation. We, at some point, stopped using our custom cryptography. Also, in story number 3, I mentioned we used reactive Cocoa with Objective-C's version 2.5, which means it's not type safe. Meaning that any observer can, in theory, receive an event it doesn't expect. So how can we ensure that any observer receiving an event it doesn't expect, it handles it gracefully? Well, in theory, we could check this with unit tests, again, with the help of subjects. But much better solution, I really hope it's obvious for everyone, would be to just move on to some type-safe implementation like combine, which again, I'm pleased to say we are about to do. Well, if our application talks to an HTTP server, it receives responses, and more often than not, responses are in form of JSON, and we need to parse JSON. So probably parsing JSON from the HTTP response is a task that, again, is perfectly coverable with unit tests. However, if you're lucky and your contract with backend is described in an open API specification, there are tools that can produce all the parsing code for you. And if you do use this approach, this parsing functionality stops being a part of your application's responsibility, but rather it's now a third-party responsibility. And usually there's not much sense trying to unit test third parties. Now let us discuss a couple of examples of things going so wrong that no amount of unit tests will help the situation. And again, I acknowledge these are pretty artificial examples. I just find it funny they are possible. Let's imagine, well, first example I call Objective-C pitfall. And in this one, we're taking a look at a class called calculator. And on the surface, what it can do, it can add to number, it can subtract number from another one, multiply numbers, and divide numbers. And also it has this piece of evil called mess with Swizzlink, and I'll explain what it does in a second. Now let's take a look at implementation. It's rather innocent. We can quickly make sure adding, subtracting, multiplying, dividing are implemented the way we expect. And also what this for thing is here for, we will see in just a minute. Well, as we want to make sure our calculator behaves correctly, we cover it with unit tests. We check that adding 2 to 3 gives us 5. Subtracting 3 from 5 gives us 2. Multiplying 2 by 4 gives us 8. And dividing 10 by 5 gives us 2. So everything is okay. And as we see, all the tests pass. However, if we try to use this calculator inside our application, the goal is to calculate 2 plus 3. And things get a little awkward as we get 4. How could this happen? Well, if we take a look inside our view controller, yes, we instantiate a calculator exactly as we did in the unit test. And we just call add 2 to 3, so everything should work fine. But as we see, for demonstrational purposes, here we call mess with Swizzlink explicitly. And now it's time to discuss what this mess with Swizzlink thing does. Method Swizzlink is a cool feature of Objective-C runtime that allows you to substitute a method implementation with another method's implementation. Don't ask me why. Well, in our example, what this method does, it takes an implementation for adding numbers and substitutes it with an implementation of method for. So this way, no matter what numbers we're trying to add, the calculator will always answer 4. And this is why you should never touch method Swizzlink. The reason I mentioned method Swizzlink at all, there was also a funny story about us learning the hard way, the reality of life, that in our iOS application we do have some singletons. And as they are singletons, for example, like UN notification center, any third-party dependency knows how to reach it. And knowing how to reach it and having this method Swizzlink, what it can do, it substitute your implementation for its own. And I tell you from my personal experience, it's so fun to debug this situation. Well, I wouldn't call this story Objective-C pitfall if I didn't have a one for Swift. In this example, we have a protocol called employee. And also we have some classes of employees. In this case, accountant, manager. And as we see, every employee, every specific employee has its job description. For example, accountant is preparing accounts and tax returns. And manager plans and promotes the daily routine of employees and the business. We also have this class developer, which is also an employee, and it has its own job description: researching, designing, implementing, and managing software programs. Oh, cool feature of Swift called protocol extension that allows us to set a default job description. And we think it's fair that if some employee doesn't have a specific job description, he might as well just drink coffee. Now we want to make sure that an instance of any class gives us the correct job description. And as we want to make sure, we cover this thing with unit tests. See if maybe you see anything suspicious. We have an accountant. An accountant's job description is preparing accounts and tax returns. We have a manager who's planning and promoting the daily schedule for employees in the business. And developers' job descriptions: researching, designing, implementing, and managing software programs. And as we see, all our tests pass. So it seems like everything is fine. Now let's try to use our code inside the application. And inside the application, what we have an instance of developer. And we want to print out, as a developer, what is my job description? Well, we tested everything with unit tests before, so we're sure everything will work fine. And I'm sure it does work fine, just as expected. As a developer, my job is to drink coffee, which I think is fair. Coffee can drink itself. And let us wrap up. So what I'm trying to say with this talk: first of all, as a front-end developers, we have to acknowledge that there is no point trying to reach 100% code coverage. And to say even more, in a broader community, there is even an ongoing debate about viability of test-driven development. And to summarize the argument against test-driven development, I would say, if you take a tool, a good tool, let's say Hammer. Hammer is an extremely good tool, but if you make using a tool a goal on its own and start applying it everywhere and push too hard, eventually it can cause more harm than good. And it is also true for TDD. And we don't want that. Although, if you see a piece of functionality that it can be naturally covered with unit tests, by all means, go ahead and TDD the hell out of it. And if you follow all the recommendations of test-driven development, you may expect all the benefits it offers. And for example, how you can recognize the functionality that is perfectly coverable with unit tests, what I believe. All kinds of pure functions. All pure functions are like that. All sorts of sorting, filtering, parsing, finding a substring in a string, finding an element in an array, etc. Or as we saw in story number 3, we can apply a little piece of force to make the code coverable with unit tests that wasn't before, but it's up to you to decide if it's worth it. And as for my story with the magic trick, remember, you know your situation better than everyone else, better than people writing books or giving talks at conferences. So if you see a problem that you can solve with, say, some unconventional use of tools, or maybe even undocumented. For as long as there is a problem being solved underneath. If you ever needed anyone's approval, now you got mine. You're welcome. Now with that, I'd like to thank you all for joining us. If you have any interest in checking out the code I talked about, like the demo with rendering views inside the unit test, or weirdly behaving examples of projects that cannot be saved with unit tests, you can check it all out using the link you see on the screen. I'll simply look up DD-KK repository on GitHub. So far, it's totally dedicated to these examples. Also, don't miss out on the opportunity to join our team. So thanks for your attention. And let me know if you have any questions I can answer for you, but be sure to pick the good ones because we have some stuff to give away for best questions. Okay?
Actually, I have 3 questions to you. So first of all, how to convince your boss that you should invest some time into testing, right? The second, what is the ratio between like production code and testing code in your application? And not related to your topic, how did you improve your English so well?
Okay, let's start with the last one because it's the simplest one. Practice.
But don't tell us that you just watch Netflix or
I don't watch Netflix. I watch YouTube.
That's it. You should talk to someone, right? Not
Well,
about listening, not talking.
You are absolutely correct. So the question is how you can improve your speaking skills with English. And the answer is if you want to learn to talk, you have to talk. There is no other way. No amount of listening can help you here. Okay, remind me other questions.
About how to convince your boss about investing in testing and the ratio between production code and testing code in your application.
Okay, I will give you my personal preference. It's not an objective truth. It's just my thinking. Okay, how to convince your boss to allocate time for writing unit tests. And I think the best reason, the best way to convince anyone is to provide specific examples of how you can benefit from it. And I don't mean in abstract terms like this will make our code more maintainable or readable or whatever. I mean specific examples. And also, as for your second question, basically how much of our production code is covered with unit tests. I can rephrase it like this, and not much. But this way, whenever we do write unit tests, we receive the most return on investment. So we spend little time, get a lot of benefits. We can show of the boss, you see, we spend this little time, receive this many benefits. Now, whenever you ask to allocate time for writing another test, your chances will be higher.
Okay,
thank you. Thank you for the question.
Yeah, I have several questions too. So, how much time did you spend practicing TDD initially when you first found out about this?
How much time I practiced preparing this talk?
I mean, how much time did you spend practicing TDD initially?
Oh, TDD. Well, considering that I already gave up the information that not much of our production code is covered with tests, not much.
Yeah, I mean that's TDD requires some practice when you find out.
Like some TDD katas or like colons or how they go.
Yes, I totally agree that writing good tests is a skill. And the question is how to develop this very skill. when, as I mentioned briefly, I didn't start with TDD in iOS. So before I started with iOS development, I learned about TDD with other technologies. But in my case, it was Ruby on Rails, and there are so many tools for TDD, BDD, whatever in that technology.
Strong culture.
Yeah. So that's how basically.
And also, I'm curious about challenges of adopting TDD in a company, because usually I find a lot of resistance. People don't want to just to try TDD. They're reluctant to even to talk about this. How did you persuade your team to use TDD?
Well, first of all, I'm a tech lead, so I basically make these decisions, and this is how I justify them. So about resistance, well, if I was asked to implement every feature with starting writing tests, first of all, that's why I started with, like, not everything in this front-end world can be developed with writing tests first. If I was asked to write to solve every issue starting with tests, I would resist to that as well. Thank you.
Is there any red flags that will show you, oh, okay, you need to stop writing tests, and some kind of balance, how to find the balance and how to understand, oh, okay, it's enough for this functionality for me.
So the question is, how do I understand that I wrote enough tests, more or less?
Yeah.
Well, you have to develop this feeling. Basically, you need to make sure that if anything goes wrong with your code, if you make any mistake you can, there will be a test that will fail. If you will have one test that fails, or 10 tests that fail for the very same reason, there will be not much additional benefit from those 9 tests. So you have to have a feeling of, am I sure that I will have failing tests if I have bugs in my code? Okay.
How do you design your testing approach? I mean, what should be covered by TDD, or maybe what should be covered by some other approaches, which I assume you have? I mean, maybe it's BDD, maybe end-to-end testing. How do you decide what should go where?
Well, specifically about TDD, how do you decide what code must be covered with tests, developed with TDD, right? I would recommend to look for pieces of code that you see can naturally be, or at least either naturally can be already covered, as I said, all the pure functions. They produce predictable output for a given input. They don't depend on any state, global state. So yeah, they are good candidates. But if you see how you can make your code predictable so that you can predict output for a given input, I would recommend to cover it with tests. And if you have a code that you can cover with unit tests, why not to apply TDD?
Let me be more critical. Yeah, that's the main logic about the TDD. Okay, but in more general purpose, how to multiply you as a tech lead to have this as a practice in the company, to not be always coupled only on your decision, what should be covered by TDD, and to extrapolate it to all your teammates. So let them also make this kind of decision, or to have this as a procedure in the company. So
as I understand the question, how can I scale ideas I have in my mind to the scale of company? How I teach other people to do like me. You give talks.
It's a part of our engineering culture right now. So all teams write unit tests, and they write component tests and end-to-end tests. It's just a piece of our culture to just write tests.
When CTO talks, you're silent. Fortunately for our company, I don't have to force anyone. It's more like they may force me.
Yeah, I have a question about some quality gates that you have on your project. So what do you use for your pipelines, and how long it takes to run all these things before release or before staging when you finish your piece of work?
Well, I'm not proud of this fact, but as I already mentioned, we don't have many tests. So the problem you're asking about is not a problem for us.
Yeah.
Just yet, at least.
Okay. And one more question about unit tests in general. As I understand, you have pretty complex combination of different styles of testing. Can you say whether it gives some positive side effect on regression and on manual testing that you potentially have in a company?
Well, basically, if you take any example, and you can imagine a scenario if we didn't do what we did, all that work would be done like with manual testing. Take for example, the store number 1. Okay, it works with iPhone 7 Plus. It didn't work with iPhone 5. So what's next? We do some changes. Yeah, we give a build to a QA engineer. It manually has to check everything works on one phone, then on the other phone, and who knows how many iterations we would need. But with having this test suite, we could see all the problems at once. And we only gave another build to a QA engineer when we already solved all of them.
I understand correctly that it's rather optimization of manual testing work than just like overlapping them. So I mean that you require manual testing even with TDD, but you can like enhance it with the fact you can provide all snapshots with different designs to designers or QAs. Is that a correct assumption?
Well, the example with designers, it's a very specific one, very specific situation. It's not how we do it usually. So I don't really understand.
I mean that, let's say you have we don't have automated tests and unit tests, and everything should be like done by manual work.
Okay.
And suddenly someone decided that TDD is needed. Let's do this approach, and yeah, it's an approach. And I see in your company it's like applied, and just want to see is there any correlation between writing test-driven development and reducing amount of time for manual testing?
Mm-hmm. Well, as I already mentioned a couple of times, we didn't have too many unit tests so that we could gather some metrics and show off, like, and answer your question. But I can only imagine that in every situation we did write tests. Manual testing would take, either manual testing would take much longer, or debugging design would take much longer, or we could run into an issue with universal links because we expect one link and we recognize it as another one. We could have an incident with that. So unfortunately, I can answer your question with numbers. But thanks for your question. Anyone? Thank you.